Yeah, let's talk about SFP. So, ito yung small form factor. So, both SFP, I have here a sample is a Huawei 10 gigabit 40 kilometer SFP. And this one is XFP specifically. So, this is a large version of the SFP. So, this is a XFP specifically. So it can run 40 kilometers away from each other using a fiber cable, a dark fiber. That's why we called it dark fiber, because there are no electronics in between the SFP. So if there are no electronics, that is we called a dark fiber. It means that only the SFP are the one producing the light and from point A to point B. So this one is a sample of a dark fiber. But if you want to maximize your fiber optic cable, you need some electronics like the DWDM or dense wave modulation. That's a single core of fiber. You can run different kinds of wavelength or lambda in order for it to maximize. One lambda can accumulate up to 10 gig of traffic. So if you want a 100G, then you can run a very expensive, that's what you call optical transport network. Okay, so very expensive to operate. So this one, you can see, this one is operating at a 1550 nanometer. It means that in a SFP, you have a different kinds of parameters. The distance is 40 kilometers away. That's the maximum. While the minimum, you can have it several meters. Then the wavelength is 1550. That is the identify the light wavelength, because both SFP must match the wavelength, because they communicate on the same wavelength. So this one has a transmit that goes in the receive side on the other side. This transmit goes to the receive side. So that's how we cross connect a SFP to SFP. And also this the light we're using are because in the light spectrum there are visible and invisible light. For the 1500 nanometer, sometimes it is impossible to see with the naked eye. That's why we are using a optical power meter. It is used to measure from point A to point B the attenuation of the fiber, because the fiber, dark fiber, the longer it gets, the larger the losses, as same with the distance principle. So the longer, the more loss you experience. So for 40 kilometers, you need to also have a threshold, receive level, and transmit level on the other side. So very useful for some data communication. And also, this is not yet a commercial SFP. I believe there are already ISP that are using this kind, but for the telco grade, this is more common, the 10 gigabit interface. By the way, if you're handling a electronics in the telco, you need to ground yourself, because these are prone to ESD or electrostatic discharge. Those are make electricity that are produced by our body and destroying the electronic components of the electronics. So that's how we are careful that we need to ground ourselves before touching this kind of electronic devices. These are just samples. So very high speed data. And this one gets very hot during the operation. That's why the routers and the switches have a fan and active cooling system. Not only a fan but also a well conditioned air controlled unit. So that's how the ISP operates, the telco, the data center. That's why their offices are very cold because these things gets very hot once they are operational. I think, yep. And because they produce a lot of laser device and suggestions, if you ever see a port that is inserted in SFP, never look at with your bare eyes. Why? Because there is sometimes invisible light that is transmitting, and it is very harmful for us humans to see that kind of device, that kind of laser, because yep, it's very harmful for our eyes. It can lead into permanent blindness if you are reckless or you're neglecting the safety precautions that was put inside here. So never look at in the direct eyes. Use only the proper equipment for this kind of device. So this one is the most commonly used high speed internet access SFP. So guys, see you around and hope to subscribe and share my channel.